Hey guys, what's up? Jed here. Welcome back to another video. In today's video, we're going to be looking at how to simplify algebraic fractions. So let's take a look at our first example. Well, first steps first, since they're being subtracted, let's try to find the common denominator. So let me show you what that looks like. We have x plus 2 over 3. I'm going to take the other denominator, so this 5, and multiply it by the numerator and denominator of the first fraction. And now I'm going to do the same to the other fraction. I'm going to take the denominator of the first fraction and multiply it to the top and bottom. So we're going to have times 3 times 3. So when you're multiplying any value onto an expression, you want to distribute that value into the entire expression. Don't forget that, okay? So the first thing we're going to have is 5x plus 10 and 5 times 3, which is 15. Okay, now we're going to have minus, and now it's going to be 3, again distributed into the entire expression. So it's going to be 3x minus 6, and this is over 15. And take a look at that. We have a common denominator. Now, when you have two fractions being added or subtracted with a common denominator, you can just write it as a single fraction. So let's see how this looks like. We're going to combine our numerators using the operations available to us. And this is something you have to be very careful about. Whenever you're subtracting a fraction, this minus operation is applied to both terms in this expression. So it's going to be minus 3x and minus negative 6, which makes it a positive. So we're going to have minus 3x and plus 6 all over 15. And if we collect like terms for the numerator, we're going to have 5x minus 3x, which leaves us with 2x, and plus 10 plus 6, which gives us plus 16, all over 15. And this is our final answer. Okay, in this example, we have denominators that are algebraic expressions. So we're going to solve this problem in the same way that we solved the previous problem. We're going to multiply the first fraction by the denominator of the second fraction. So we're going to have this x minus 2 multiplied to top and bottom. And for the second fraction, we're going to multiply it by the denominator of the first fraction. So we're going to have x plus 4 multiplied to top and bottom. Now we actually carry out the multiplication. So it's going to be an expression multiplied by an expression, which is essentially expanding two brackets. So we're going to have the following, which is x minus 2 multiplied by x plus 1 and 7 multiplied by x plus 4. And this is all over x minus 2 multiplied by x plus 4. Now, since we have a common denominator, we can write these two fractions as a single fraction, which looks like this. And then we can now expand all of the brackets and simplify. So that's what I'm going to do next. We're going to have x multiplied by x, which gives us x squared, x multiplied by 1, which gives us plus x, minus 2 multiplied by x, which gives us minus 2x, minus 2 multiplied by 1, which gives us minus 2. And then it's going to be 7 multiplied by x, which is plus 7x, and plus 7 multiplied by plus 4, which is plus 28. And this is going to be all over x multiplied by x, which is x squared, x multiplied by 4, which is plus 4x, minus 2 multiplied by x, which is minus 2x, and minus 2 multiplied by 4, which is minus 8. And now if we collect like terms, since we only have one x squared in the numerator, then it's just going to be x squared. And now if we collect our x's together, it's going to be plus x minus 2x, which is minus x, plus 7x, which will leave us with plus 6x in total. And now for the numbers, we have minus 2 plus 28, which will give us plus 26. And that's it for the numerator. Let's do the denominator now. So again, there's only going to be one x squared here. And now plus 4x minus 2x, which will give us plus 2x. And finally, minus 8. And there you have it. We have fully simplified an algebraic fraction. Okay, in this example, we're given a single fraction and we're going to be asked to simplify this fraction. How you simplify a single fraction such as this is by factorizing either the numerator or the denominator or both, and then cancelling terms out. So in this case, the denominator, just looking at it straight away, is x plus 2, we're not going to be able to simplify this any further, so it's going to stay as x plus 2. However, the numerator is a quadratic expression, and you should know how to factorize quadratic expressions if you are dealing with algebraic fractions. So let's go ahead and factorize this quadratic expression. Quadratic expressions factorize into two brackets, and we're going to need to find two numbers that multiply to give us 8 and add to give us 6. This is going to be plus 2 and plus 4 all over x plus 2. Okay, this is what we get after factorizing the numerator, and it's still over x plus 2 the denominator, which hasn't changed. And what you can see after factorizing is that one of the factors in the numerator is identical to this expression here, x plus 2. And what that means is, since the top two expressions are being multiplied together, you could just go ahead and divide this expression by this expression. Anything divided by itself gives you 1, and 1 multiplied by anything just gives you that very thing. So the x plus 2 and x plus 2 cancel out, leaving you just with x plus 4. And this is how you fully simplify an algebraic fraction when they just give you a single fraction like this. I'm also going to note that the denominator is usually a hint at what the numerator is going to factorize into. So if you see an x plus 2 in the denominator, chances are that the numerator is going to factorize into x plus 2 multiplied by something else. And it did in this example. Okay, for our final example, we have another single fraction. However, this time it looks a bit peculiar. We have a quadratic expression in the numerator and a quadratic expression in the denominator. How do we proceed with such an example? Well, we have to factorize as much as possible. So I'm just going to go ahead and begin factorizing. In the numerator, I can see that 2 is a common factor of all three terms. So I'm just going to pull that one out and have x squared plus x minus 12. So I haven't really factorized the quadratic. I've just seen that there is a common factor of 2 in each term, and I've just gone ahead and factorized that out. And with the denominator, you can see there's also a common factor of 2 in each term. So I'm going to go ahead and factorize that out too, which is going to give us x squared minus 16. And from this stage, you can see that the 2 over 2 can cancel out to just leave us with x squared plus x minus 12 over x squared minus 16. Now we can go ahead and factorize these quadratic expressions to give us the following. We'll get this after factorizing the numerator. And the denominator, if you can see what this expression is, it is the difference of two squares. So we can actually go ahead and factorize this one into two brackets as well, x plus 4 and x minus 4. And you can see here that the two x plus 4s can cancel each other out, leaving us just with x minus 3 over x minus 4. And this is the fully simplified form. Guys, thank you very much for watching. I hope you've learned something by watching this video. If you have any questions, please leave them in the comments. We look forward to reading them. Thank you and take care.